Okay, so we just finished solving systems of two equations and two unknowns. So, and we could either graph them, use substitution, elimination by addition. Well, we're going to head now into solving systems of three equations with three unknowns. So if there are three unknowns, like x, y, z, let's add a third variable in there. I wanted you to have an idea what that looks like graphically. Okay, because now we're not into 2 dimensions anymore, guys. We're into 3 dimensions. Okay, so let's look here. If instead of an ordered pair, x, y, we're going to have an ordered triple, x, y, z. This is kind of a 3-dimensional graph paper. We have the x-axis, which is horizontal here. The y-axis is coming out towards us, okay? And then the z-axis, it's sort of like the xz looks like what the xy used to look like, okay? And then we have this third dimension. I hope you can tell. It's hard to show 3 dimensions using 2 dimensions, but that's what we're going to try to do. So 3, 2, 1. The point 3, 2, 1 would be on, I'd go 3 in the x direction. Now notice when I go 2 in the y direction, I'm going to go parallel, parallel to the y-axis, okay, and go 2 spots. So here's 3, 2. Now I need to go up 1, right? Isn't that what I said? 3, 2, 1? Yes. Okay, so I go 3, 2. Now, can you imagine if I'm going up? I just want to go up this far, okay? But out here at 3, 2, up 1. So about, might have been nice if I picked up the pen. About here. Can you see it hanging in space? 3, 2, 1. Okay, I went 3, 2, and then up 1. When I went up 1, I had to go parallel to the z-axis. So it's like it's just hanging out here in space. Okay, now the point 1, 2, 3, then I would go 1, 2, and then I'm going to go up 3. Okay, parallel to this axis, up 1, 2, 3. Okay, 1, 2, maybe about here. Okay, it's hard because some people want to go up, this high for the 3, but it's like I'm already over here. There's 1, 2, 3. There's 3, 2, 1. Okay, it's in 3 dimensions. All right, so this is sometimes what they'll show to look like the 3 dimensions here. We have the positives and the negative x, okay, positive and negative y, positive and negative z, okay. Forgot to put the negatives there. All right, so here's the x-axis. Y-axis is kind of going this way. This time they have the positives over here. It kind of depends. Each 3-dimensional axis you have to kind of look at, and they're not always the same. In fact, I've seen some where the z-axis is this axis and the y-axis is vertical. So just know this goes in order x, y, z. We have an origin in 3 dimensions, just like we had an origin in 2 dimensions. Now, if we're going to graph a plane, then what we do is graph the intercepts. Okay, so I'm going to put 0 in for x, 0 in for y, and see what I get for z. I would divide by 2. It looks like I get 4.5. Then I'm going to put 0 in for x and 0 in for z and see what I get for y. Y would be 9. And then I'm going to put 0 in for y and 0 in for z and see what I get for x, which I would also get 9. Okay, so to graph this plane, I go 0, 0, 4.5. Okay, so 0, 0. It's hard to see on here. 1, 2, 3, 4.5. And then I would do 0, 9, 0. So on the y-axis, I'm at 9. I think I was going, let's have this go by 2. So 2, 4, 6, 8, 9. So my 4.5 would actually be at 2, 4, a little bit about here. And then my x-intercept is also 9. 2, 4, 6, 8, 9. Okay. And then we just kind of, it's the intersection. I don't know if you can see. A lot of times they'll draw a triangle and they'll say, okay, it's this plane that has this triangle in it. Okay, that covers this. That's anything that's in this triangular plane are the answers to, okay, the whole plane. Okay, whoops. And that plane goes, infinite directions. And it's just in each direction here. It's just, but it holds those 3 points in it. Okay. Anyway, we don't have to do a plane that often. Okay. All right, let's take a real life problem. 3 people purchased items at a bake sale. Lori got 3 cookies, 4 cupcakes, and 5 brownies. This is making me hungry. And paid $22. Pam got 2 cookies, 5 cupcakes, and 7 brownies and paid $23. Steve got 4 cookies, 3 cupcakes, and 6 brownies. They're arguing over how much each cost. Okay, they're sitting, eating a couple of their treats off and out the side. And they were like, how much was a cookie? I don't remember. I just know that I paid $22. Okay, so they could easily solve a system and figure this out. Let's let X be the number of cookies, Y be the number of cupcakes, and Z be the number of brownies. Okay, and I have 3X plus 4Y plus 5Z. That actually added up to $22. 2 cookies, 5 cupcakes, and 7 brownies added up to $23. And 4 cookies, 3 cupcakes, and 6 brownies added up to $24. So we have this nice system. What we're going to do is this time take 2 at a time and make sure that we eliminate the same variable. That'll give us a system of 2 equations and 2 unknowns to solve. Okay, so let's look here. I have my 3 equations. What I'd like to do is take 2 at a time and decide which variable I'd like to get rid of. So I'm going to take the top, these 2. 2x plus 5y plus 7z equals 23, 4x, okay. I'll take those 2, and the other 2 I'll put together are these 2. And I think that I am going to decide to get rid of, I'd like to get rid of x. Okay, so in order to do, the reason is because I'm looking here and it looks like I could just multiply this by -2 and get the x's to cancel. Okay, so I'm going to multiply everything here by -2. That'll give me a -4, a -10, a -14, and a -46. I'll add this together and get -7y minus 8z and equals -22. Okay, now I have an equation with 2 variables and 2 unknowns. To get rid of the x's here, I'll multiply this bottom one by 3, maybe by -3, and the top one by +2. Okay, that'll give me 6x, 8y, 10z, 44. This will give me -6x, -15y, -21z, and negative 69, I think. Okay. Adding these together then, the x's cancel. I get negative 7y, negative or minus 11z equals negative 25. Okay? So now I can put those two equations together. Negative 7y minus 8z equals negative 22. Negative 7y minus 11z equals negative 25. I think now I'll get rid of the y's. I'm going to multiply this whole bottom one by positive, and that'll give me 3z equals 3. So I know that z is 1. Cost of a brownie, $1. Okay. Well, I'd like to figure out y. So negative 7y minus 8 times 1 equals negative 22. Negative 7y equals negative, let's see, if I add 8, that'll give me 14. And then divide by negative 7, it looks like y is positive 2. $2 for a cupcake. So to figure out x, I'll just put 2 in for y, 1 in for z, 8, 9, 10, 11, 12, that's 13. Subtract 13 from 22. It looks like 3x equals 9, so x was 3. That was a big cookie. Okay, and you can double check it with, if you would like, but that's what you do. Okay, the key is picking two equations. We picked what? We picked these two and those two. Okay, and then you had to eliminate the same variable. Sometimes people pick these two and they eliminate x, and then they pick these two and they eliminate z. They're like, whoops, now I don't have two equations with the same two unknowns. Okay, a solution to a system has to work in all three equations. So if I would try 2, 1, 2, that would mean x would be 2, y would be 1, and z would be 3. It would have to work in all three. Okay, and it doesn't. Again, graphing, I'm just trying to show you how, if I'm graphing negative 4, negative 5, and then I want to go up 6. Okay, it's kind of hard to see, but it's like it just looks like it's hanging out in space. That's how we have an ordered triple. Graphing the plane is very similar. We substitute zeros in for x's and y's, 0 in for x and z, get that, those intercepts. Okay, so I would get the intercepts, 0, 0, negative 4, 0, negative 12, 0, and 6, 0, 0. Plot those points, 6, 0, 0, 0, negative 12, 0, etc. 0, 0, negative 4, and then draw this little triangle. And it's the plane that holds all the XY points that work, XYZ points. Okay, here's where we have systems and zero equations. I mean, inconsistent. There's no point that satisfies all of them. Okay. Here we have dependent system because we have a whole line that satisfies the equation. There's another picture of a dependent system. Where's the, okay, I guess that was it. Okay. And there's your homework. I have that written in Schoology as well. Okay, not too many. And then there's also a quizzes that I'd like you to do. All right, gang. I will see you in school on December 1st. Bye.